Welcome back. This is module 1. In this video we're covering the Fusion interface, the basics of sketching, how constraints work and why components matter. If you get these 4 things right early on, Fusion becomes a lot easier and you make fewer mistakes later when you get into the CAM. First, let's get comfortable with the Fusion layout. Up top you've got the toolbar. This changes depending on what workspace you're in. We'll be in design for now. On the left is the browser. This is your model tree. It homes sketches, bodies, components, construction geometry and origin planes. At the bottom is the timeline. This is Fusion's history. Every feature you create shows up down here and you can roll back, edit or reorder things. On the right you'll usually see the properties modified panels depending on what tool you're using. Now for navigation, to orbit, you'll hold the shift and the middle mouse button, then move your mouse around. To pan, just hold the middle mouse button and move your mouse around. Zoom's on the mouse wheel. And to go home, or if you lose your model, click the home icon in the top right hand corner. You use that constantly. Also, hit the save button as many times as you can remember as you're working. Fusion crashes at the worst times, so although it auto saves every 5 minutes, you can get a lot of work done in 5 minutes, and when you lose it, it's really frustrating. Okay, now we're going to create a sketch. First off, we're going to right click the top, new component, name your component your part. So box, we've got our box. Note the little bullet highlighting that we're working on this component, and then if you've got many components and you're working across everything, you want to be in the top of your tree. For the moment we're going to be doing our box. I'm going to click create sketch. Actually, let's save it, shall we? Box 1. Save. So now we're going to click on create sketch, and you're going to have to go in X, Y, XZ or YZ, or select any flat face that's on your model already. So I want to work on XY, which is the top. Move our view cube round. I'm going to select that face, so now we're on the XY plane. We're going to select a square. If you click create, all the tools you can use in the sketch are in this field. So we're going to start with a box, draw a box, 150, use tab to shift over to the next dimension, 150. Hit enter. Our lines are blue because they're not constrained, so you can move them about anywhere, which is bad, so we need to constrain them. So up the top we've got sketch dimension. You can see in the field, if you hover it over it for a while, it says D in brackets, so your keyboard shortcut is D for dimension. So if we use that, and then we go from our data point, we do the maths in the field, so 150 divided by 2 to put that on center. Do the same again in X. There we go. Now we're all black, fully constrained. Sorry for the clicks. I need to get a different keyboard for the videos, I think, because the mechanical I have to use when working is very noisy on the video. So now we are finished, we can finish our sketch, highlight the internals and use extrude. So this is going to create the box. So the arrow's facing up, I want to go down, always work from the top down, so I'm going to go minus 150, and that's lowered my box, created my box. So what we done there to constrain that we could have used a centre rectangle instead, which is faster because we don't have to constrain it from the centre, it does it automatically. So now if I just put in my 150 by 150, you see the diagonal construction lines already going through. Because we selected it from our datum point, it's already constrained, so there is no need to constrain it to centre. It's done for you already. So same again. So now we have our box. So if we were doing a turned part, let's create a new component. This is going to be our bush. So we can turn off the box, don't need to see that. Sketch again, go from the top face. Actually, because we're doing a turned part, let's do it from the front. So if I go back in, we created that sketch. I'm going to delete that sketch. Create it again. I want to be on the front this time. When you open a sketch, you have this field, which is your tools that you can use in your sketch. So we are going to use a centre line because we're creating a turned part, a revolved part. So let's say that's 150mm tall. I'm going to select the line and then I'm going to select centre line. So now when you're doing a model of a turned part, you can have the diameters on the drawing, and it makes it a lot easier just to put in a diameter or the dimensions straight from the drawing. Oh, let's put a bore through the middle, shall we? So I'm going to trim these excesses here. That's not a line. There we go. Oh, we've taken that one off completely. Okay. So you can see it's gone, because it's a enclosed shape, it's gone light blue, pale blue inside. So we know that all lines are touching. I'll do my centre bore, 250, 25mm. So that's gone on diameter. You can see the centre line. I've put in from the centre line to my wall of my internal bore 25mm, but from the centre really it's 12.5mm. OD, that goes wrong. Just hit escape. If you click the wrong thing, let's go 50mm on the OD, 40mm on the groove. Then we will have three lots of 50. Right, so you can see that although I've dimensioned the end face, the top of the groove, the bottom of the groove, they're still light blue or blue. They should be black, they need to be constrained. So we need to use the coincident, and we're going to take our top line and lock that to the datum point. Then all becomes black. He says this one's still blue. What's that doing there? That was at the bottom of our centre line. So let's go put that in again, 150mm. So because that 150 was dimensioned to the bottom point of our centre line. Now we're ready to revolve that. So if I select that part there, hit revolve, turns it into a turned part in seconds. There we go. So a few things here. The sketch, as soon as you make a sketch, name it straight away, because if you're doing a complex part, you're going to end up with loads of sketches. In some parts I can have 50 sketches in. You need to make a sketch in order to make another sketch, to make another sketch, to make the feature that you're trying to make, especially if it's a 3D feature. So if I just put main profile, ooh. And then it just makes it easier if you've got to come back and edit things, or if you will need to use a sketch to make another sketch, you can just find things straight away. And then turning it on and off is just the eye. So now to add chamfers, we could have put chamfers and fillets in the sketch. If I double click the sketch, go back in, I've clicked the chamfer tab, put one there, say 1 mil, one there, hit enter. Just put my chamfers in on there. So the problem with that is, well, it's not a problem, because if it's supposed to be there, it's there, but we've put them in, they belong to that sketch. A lot of the time I will do it as a solid body, so we've got our features used sketching and from our sketch here. Then we can modify the solid from this section here. So if I click chamfer there, and I do all the outside ones, 1 mil, hit enter, put 1 mil chamfer on the outside profiles, it goes down to our tree, our history, sorry. So in our history we can roll back, which will turn them off. We can suppress it, which sometimes you need to do to help you machine a feature. You might need to suppress a feature. It does happen. So unsuppress that, and then we can just remove it. So removing things from your timeline can be a pain, because you can create other features which needed that feature in the first place. Then you get a yellow highlighted mark with an error. So you need to be careful that the timeline needs to be looked after all the way through your model, to do things in a sequence that you'll pick up as you work through it. And the more models you do, the neater you'll become. Okay, now we're going to go through sketch constraints in a little bit more detail, all the ones that you need to use to make sure that your sketch is fully black. You don't want any blue lines. It's really important, especially when you're making a model or part that you want to be perfect, because accidents happen, and if it's not fully black or fully constrained, then it can move by accident and you're going to end up with a rubbish part. So if I just draw some random lines, our first one in the constraints field, horizontal vertical. So you can see at the bottom I drew that by accident perfectly straight, so it's automatically put a horizontal constraint on that line as I drew it. So if I select this one, that's now vertical, that's horizontal. So all 4 lines are horizontal and vertical to my sketch plane. So that one coincident, so that will pull a line to the point. Let's read the description. Constrains a position of 2 points, or a point and a line or curve together. This could be a point constrained along a line, 2 points constrained to each other, or a point constrained along a curve. So for me, I use this a lot if I'm pulling in a line to my datum point. So that's locked in. It's the same if you want that not to leave. It's already been. Let's delete the point. another one in. Coincident. So it's because when I drew it on there, Fusion automatically added the coincident constraint to the point, but it just pulls it in, so that's locked in. Tangent, so that will lock a curve or circle to a line, so that's pulled them in. You can just delete your constraints, click them and delete. Sometimes you will want to click and hold because you can't select it properly, so if you do that, it gives you an option that you can then choose which one you want. That's very helpful sometimes. Equal, so if I had a circle and another circle, let's dimension that one 200mm, and I want them to be equal to each other, I can use that. So I've got one dimension at 200mm, and it's no matter what I change this one to now, the other one will change the same. So if you're making a model where maybe you have well, if there's something the same, say a feature that's going to change because another feature is changing, this is basically making it parametric. Then we have parallel. So to use that, we are probably going to have to delete these constraints. I want that top line to be parallel to that one, so no matter what, that line's always going to be parallel to that line, and then we can have the same on these two sides, so they can't go wafty. Perpendicular, that one line to another, 90 degrees. Might be over constraining it because we've got the parallel lines in it. No, that's fine. So now that line and that line will always be 90 degrees from each other. That's over constrained. Oh, and then the rest are all parallel, so that will all add up. You've got fix and unfix. So this will be if you didn't want something to move, you've not constrained it with something, but you just don't want it to move from wherever it is in space. So if we hadn't had the coincident on this, we fixed that, and then we can dimension from that without that part moving. Take that off. Midpoint, this is something I use a lot. Fusion will automatically add this if you hover over the line with a point, or whatever you want, circle. It will give you that triangle symbol which highlights you're in the middle of whatever geometry that you're on. So for that line, I'm in the middle of that line. If you want to make sure, you can stick it anywhere and then select the two, just pull it into the middle. Concentric, so this is to make sure two circles are going to share the same centre. So if I click that one and then that one, that's pulled them in, although you can't see both of them because they're equal to each other. So let's delete the equal constraint. Now you can see two circles fully concentric and locked in to each other. Collinear, this is one I don't really use, but well, we've drawn that already. Collinear, so we've pulled another one, made another line there. If I wanted to make sure they were on the same line, we just pulled that in. And that's it. So for the constraints, that is the main ones that you need to make sure that your sketch is fully constrained. Okay, now we're going to talk about components and how important they are. If you're just creating a single model and you're going to machine it just as without adding in any work holding or fixturing, or it's not a part of an assembly that you need modelled all together. It's not really important, but if you do any of them things, you need everything laid out in components. So the main thing about that is it's like having an extra folder that everything to that component or body is held together in one place. To give you a better understanding, so if I go up to the main level and I create a sketch on my box, I've got engraving on my box. So I'm going to create some text on the top face. Hopefully my spelling is okay. So I've got my text should be stuck to my box. Let's unground that so we can move it. So now if I move my box, my writing is not going. So my engraving is staying where it is because it doesn't belong to the box. Although I want it to, and I put it on that face, it's irrelevant. It's completely disconnected, which is no good. So in this instance, I can drag that sketch into the sketch for the box, so it stays within that folder. So now when I move my box, my sketch moves with it. It's united, which is how it should be, how you need it to be if you're going to pull in work holding or have a body that's a part of an assembly. Each body really needs its own folder, and for that to happen it needs to be a component. So any time that you make a new part to add to your existing assembly, you want to right click up the top, new component, add a new component. So now we've learnt about the layout, the browser, the timeline, the toolbar, sketching on the correct plane, using constraints and dimensions to fully define sketches. Blue is underdefined, black is fully constrained, and used components to keep parts organised. In the next module we'll build on this and we'll start modelling more intentionally so your designs are clean, editable and ready for CAM.